Good afternoon. My name is Kit Bui from Big Data. Thank you very much for attending our presentation today. In this presentation, I'll describe our system submitted to the VLSP machine translation share task for Chinese-Vietnamese. First of all, we would like to discuss a little bit about the challenges of Chinese-Vietnamese machine translation task. Then, we will be presenting in more details about our system, including the training data, system overviews, results, and discussions. As the first step when participating in this trade task, we briefly review the recent progress in machine translation. For instance, we show here this SMT system from 2016. The blue score is around 31. And this is a recent work this year. They trained neural-based systems on 500,000 bilingual sentences, and they reported the blue score of 25, which is still somehow not high enough. We found that there are few existing systems on this language pair, and the amount of available bilingual data is also very limited. These two reasons cause the task to be very challenging. For the shared task training data, we are provided with 300,000 bilingual sentences of Chinese-Vietnamese. Both of the validation and public test sets contain 1,000 sentences, and the organizer also provided a large amount of monolingual data with around 20 million of sentences. For our system, I'll first show you this overview of our system. We use the bilingual data to build the baseline systems. For the baseline, we use the transformer model and the pre-trained MBART. We will present in more details in the next slide. The baseline system are used for back translation to take advantages of the monolingual data. And this is just a very common strategy for improving MT system. We also apply several techniques for back translations. For instance, we first filter the monolingual data based on the sentence length, because we found that the length from 10 to 60 covers more than 90% of the bilingual data. As a result, we selected 1.5 million monolingual sentences, then translated by the baseline to get a synthetic data. We then also apply a sampling method for back translation, which I will be discussing later. After that, we continue to filter to keep sentences pairs based on the length ratio. We use the ratio of 1.2, which means that the ratio between the lengths of Chinese sentences and the Vietnamese sentences is 1.5. 1.2, my bad. We combine the synthetic corpus and the bilingual corpus to train a back-translated system, and then we use an ensemble method and post-processing, which we'll discuss in the following slides. This is the detail of our baseline. We built our baseline system based on the well-known transformer model using Facebook FAIRSEC framework. The model is fine-tuned on the pre-trained MBART 25 model. This pre-trained model is trained on 25 languages, including Chinese and Vietnamese. Texts are tokenized by sentence piece, and the model is optimized by the Adam optimizer. We use the MBART pre-trained model, in which the vocabulary is 250,000 tokens. However, when we fine-tune on our machine, which is an 11 gigabyte GPU, it causes out memory problems. Therefore, we filter out the vocabularies, which we keep only the vocabs in the bilingual and the filtered monolingual data. The corresponding filtered out embeddings become zeros. By doing this, we overcome the issues and we can train the model on a limited computational resources. We apply the sampling method proposed in 2018, in which synthetic data is generated based on sampling from model distributions, which they show that is better and richer information than the pure beam search. We train the model with early stopping, and for the detailed hyperparams, you can check our paper that which will be published soon. We apply an assembling method in which we calculated the average model's width of the last 5 checkpoints. We also, finally, use a post-processing step to correct mistranslated values. Because translating numbers is also not a straightforward task, we analyzed translation outputs and found that numbers and date can be easily mistranslated. Such values, for example currency, are very important and need to be translated correctly. Therefore, we created a list of patterns to correct values. For instance, this unit is equivalent to 100 millions, and this is equivalent to 10,000. We will now present the results. In order to build a strong baseline, we first review and conducted experiments to compare with several recent methods. For instance, the methods focus on optimizing loss, name entity, and different methods to use pre-trained models. Due to the time limitations, some results are yet completed. However, we can observe that the FASEC model is more powerful and we choose it for our baseline. For the main results on translations from Chinese to Vietnamese, we found that the baseline score is quite high with 38 plus score. We get the improvement mostly from back translations. And sampling slightly improved the results, and post-processing did not improve plus score much. For translation from Vietnamese to Chinese, we get the improvement from back translation also. We will present several analyses and discussions. Although post-processing did not improve blood score, we found that several mistranslated cases can be corrected by post-processing. In addition to the blood score, we would like to investigate the translation quality from expert viewpoints. We invited a native Vietnamese speakers who graduated from a Chinese university in linguistics to check a small set of the translation outputs. The expert will give score from 1 to 10 for each translation. The output is shuffled between the enhanced and baseline systems so that she did not know the output came from which system. She also gave comment on the translations, and we found that most outputs receive a score from 7 to 10, which indicate that the translation quality is quite good. Also, for 70% of the samples, the enhanced system output receive a higher score. We show here a sample of our human analysis. And finally, this is our last slide. After participating in the stress test, we got several observations. The baseline scores looked promising. Common strategies that we use are helpful on this language pair, such as back translation and sampling. However, we found that there are still limitations that we need to solve in future research. For instance, the translations are partly correct, or sometimes the meaning is acceptable but choosing inappropriate words. We need to take advantages of the large-scale data also. Or finally, we need to consider using specific linguistic knowledge focused on Chinese and Vietnamese languages. Thank you very much for your attentions, and you can also contact us via these emails. We would like to receive your comments or any questions. And once again, thank you.